Hi, I'm gonna explain how to solve problem 3 for Physics 2 partial exam. The problem says like this. A clock uses a physical pendulum which consists of a uniform thin rod with mass m. This is the rod with mass m. And length L that is pivoted freely about one end with a solid sphere of radius L over 2 and the same mass, that is m. Center about the free end of the rod. We have first of all to obtain what is the rotational inertia of the pendulum about its pivot point. So here I'm gonna write A. For obtaining the rotational inertia, we have to consider the parallel axis theorem that says like this, that the total inertia is equal to the inertia of the center of mass plus the mass times the diameter square. So we have first of all to obtain the center of mass. So we know that the center of mass is this part. So it's not the half of all the rod. It's like said 3/4 because we can divide the rod in 4, 1, 2, 3, and 4, and here in the 1, 2, 3 from the pivot, it's 3/4 of the length. Okay. Once we know this, we can use our theorem and say that the total inertia will be equal to the inertia of the rod, the inertia of the rod, that it's this one, plus the inertia of the sphere. But the inertia of the sphere, it's divided in two. Here we have that the inertia of the center of mass of the sphere plus the mass plus the mass times the L cube. This L cube, this L square, it's the diameter. So here we have the inertia here, and then we add the center of mass of the sphere, and we add the mass times the length square, that it's the diameter square. Once we obtain this we know this is from the rod and this is from the sphere. Then we can obtain that the inertia of the rod, as we are given in the problem, the rotational inertia from a rod of length L, it's equal to 1/3 ml squared. And this we have to add the inertia of the sphere, that it's also given in the test, that says that the rotational inertia for a sphere of radius r is 2/5 mr2. Okay, once we know this, we can add finally the mass that we know times the L square. Okay, once we know all these variables, we can obtain the total inertia by only solving these equations in terms of the m and the L. So we obtain that, well, here the radio, we know that it's equal to L over 2 because it says here. So now we have our equations in terms of L and M's, okay? And as by solving this, we can obtain that the inertia is 1/3 plus 2/5 times 1/4 plus 1 times the mass times the length square. And we obtain finally that the inertia it's equal to 43/30 mass length square. Once we know this, we can go to step 2, and it says like this. What is the period of the pendulum for small oscillations? Here we can use now our formula of physical pendulums with the tension. So we have to, with the period, sorry, we have to obtain the period. Here I'm going to write that the period it's equal to the formula, okay? M total GR. Well, now we know the value of the inertia. So we can substitute the two like this. The inertia that is 43/30 meters, well, not meters, the mass L squared, over, we know that the total mass it's 2m, because we know that this is m and this is m, so we have 2m times the gravity times the radius that we know that these are, it's according to the formula, the distance from the pivot to the center of gravity. So we have that the R will be equal to 3/4 L. That it's the same as the center of mass because it's from the pivot to the center of gravity. Okay? Once we know this, we can take the m's out, we can take 1L out, and we are left with 2 pi for 43 L over 6 times 30. This one's this one, and this one is this one. Gravity. Okay, now we have this equation, and by solving this per this and this per this, we obtain that the total period it's equal to 2 pi times square root of 43 over 45 liters over gravity. Length over gravity. Okay? And then we can solve the part 3 that says like this. For a period of t equal to 2 seconds, what should be the length L? Okay? If we know that the t will be equal to 2 seconds, we can say that t, as in this formula, it's equal to 2. T is equal to 2. So we can write here that 2, it's equal to 2 pi, and we already know these values, so we write them here, 43 over 45 LG. We have to obtain the length, so we have to get out of the equation the L. So by taking out the L, we obtain that the L will be equal to 45 over 43 times the gravity times pi per 2. Okay? And once we know these, we only have to solve it to obtain that the length will be equal to 1.04 meters. And these were the 3 parts of the last problem of Physics 2 partial exam.